in the previous class, we went through a little bit of basics of triangles, right? We discussed about similarity, what similarity means, and how it is different from congruence, right? So everyone understands that?
Yes, sir.
Okay. So for triangles to be similar, what are the two conditions we discussed?
Angles should be equal.
Angle should be.
Okay, very good.
And
And
the sides should
Right? The proportion of the side should be
proportion.
equal to this.
yes, the sides should be in the same ratio, or which we also call it as the sides should be proportional to each other. They should be in proportion with each other. So today we are going to start a very, very important topic, basic proportionality theorem. This is also called Thales theorem. And this basic proportionality theorem, you would hear it as, your teachers may call it as BPT in short. Basic proportionality theorem, in short you call it as BPT. But don't write BPT in your exams. Use basic proportionality theorem. You people will not use shortcuts, okay? So first of all, we'll understand what it tells, and then we will prove it also. Okay. So of course, we are studying about triangles chapter. So this is related to triangles. So let's say we have a triangle ABC, like written over here, drawn here. This theorem tells you that if you draw a line which is parallel to any one of the sides, I can draw a parallel line parallel to any of the sides. So let's choose this BC. I'm going to draw a line which is parallel to BC, and it intersects the other two sides at this and this point. So let's give them some name. So let's say this is D and E. So as of now, I've told you what is given. What do we know? I know that DE is parallel to BC. This is the only thing we know. And we know that D and E are the points where this parallel line intersects the other two sides. Remember, D is parallel to BC. So the other two sides will be this and this. Now, BPT tells you that if this is the case, if D is parallel to BC, then the sides are divided in equal ratios. Which sides? AB and AC, they are divided in equal ratio. What I mean by that? It's very simple. If D is parallel to BC, then AD by DB is equal to AE by EC. You see, this by this is equal to AE by EC. So confirm all of you. Do you understand what is happening in this theorem first of all? A line is parallel, and if it is parallel to the base BC, then it will intersect the other two sides at D and E. Then AD by DB will be equal to AE by BC. This is what your BPT tells you. Is the concept clear to everyone? What is happening here? Why it is happening? That we will prove now. Let's do a little bit of construction. And by construction, I mean, we'll just add a few lines over here. So what I'm going to do is I'm going to join this B with E. And I'm also going to draw a perpendicular from this point D to the side AC. And it'll be something like this over here. Let me call this point as M. In same way, I will drop another perpendicular on this side and I will call it N. Okay, so this is the construction. Okay. So what strategy we are going to use to prove this idea, whatever we have here, is we are going to take the area of this triangle ADE. Okay, take the area of triangle ADE and divide it by the area of triangle BDE. Area of triangle ADE divided by area of triangle DBE. So I will get my AD and DB in that ratio. I need AD by DB, no? You know, right? I have half into base into height. So I will consider AD as the base ones and DB as the base ones. So I will get my AD by DB if I use these two triangles. Area of triangle ADE and area of triangle DBE.
Sir, I have one question.
Charan, say that again. I couldn't hear you.
I have one more idea, sir. We can take the triangle BD and that we can put that intersecting point as O, sir. Then we can prove that triangle BDO and CEO are equal. Then BD will be equal to CE, sir. In same way, triangle D AD.
Hold on, Charan. See, first of all, we need to understand that I am not saying that DB is equal to EC. They are not equal. Remember, I'm only saying that AD by DB, whatever is the number, let's say if this is 3 centimeter and this is 5 centimeter, then this, or let's say this is 6 centimeter. So what is the ratio AD by DB? It is 3 by 6. That means it becomes 1 by 2. So this ratio also will become 1 by 2 only. So if this is 2, this will be 4. So we are not saying that DB is equal to EC. Keep that in mind. So there is no congruence here. We are not going to prove that DB is equal to EC. So keeping the O over here, we will not be able to prove that these two triangles are congruent or anything. Is it clear? All right. So let's get back to what we were doing. I said we will take this triangle and this triangle, ADE and BDE. So for triangle ADE, what can I say? It will be half into base into height. So of course I would want to keep the base as AD, right? I need AD by DB. So I will keep the base as AD and height will become EN, correct? Area of triangle ADE is equal to half into AD into EN, half into base into height. Simple idea. Try to understand that. Everyone is clear with that or not? Tell me.
Yes, sir.
Yes, sir.
Okay, so this is the base and this becomes the height. Now, for the area of triangle BDE, I will consider base as this BD. Now, you people tell me, what is the height for this triangle? If I want to find the area of BDE, what is the base I want to keep it as? BD or DB, whatever. What is the height for this? Look at the triangle BDE. This is an obtuse angle triangle. So if I want to drop a perpendicular to this base, I will have to extend it and the perpendicular will be this line EN, right? Let me redraw this figure for you. See, this is your triangle E, B, E. Where will be the perpendicular? Perpendicular will be somewhere over here, no? You'll drop the perpendicular. Are you people able to imagine this? This is the base and height is nothing but this guy, En. Tell me guys.
Yes, sir.
No, sir.
Not able to understand? All right. Let me turn the triangle a little bit upside down. See, when we have a acute angle triangle, we know that the height comes inside the triangle, correct? But what happens when we have an obtuse angle triangle? The height goes outside, no? We have to
Yes, sir.
this becomes the height. So try to see same thing over here. The triangle is turned a little bit by angle. This is your obtuse angle, and I have dropped a perpendicular here. You're able to see that En is the height for this. If I keep dB as the base, then En will become the height.
Yes, sir.
Making sense now? Now try to see the same thing over here in the our original figure. dB is the base, so height will be En, which is perpendicular to this line AB.
Yes, sir.
Okay, everyone able to see now? Okay, so for that, what will happen? Area of triangle BDE will become half into base dB into height again En. Confirm all of you. Everyone is able to understand this part. En, I mean to say.
Yes, sir.
Okay. So as you can see here, half and half, En and En is common. So they'll get cancelled, right? And I will be able to write this thing that area of triangle ADE by area of triangle BDE is equal to nothing but AD by DB. Okay, everyone okay with this up to this so far?
Yes, sir.
Okay, now
Yes.
we will do the same thing on the other side. We will take the same triangle over here, ADE, and this time we will divide it by the triangle, area of triangle DCE. And in ADE, this time we will consider AE as the base because we need AE by EC. So I'll consider AE as the base for the triangle ADE and EC as the base for the triangle DCE. So now you should have some experience. If I keep EC as the base, what will be the height for this triangle? Tell me. DM, right?
MN.
DM, sir.
DM, yes. So if EC is the base, DM will be the height. So area of triangle ADE again, but this time in the denominator, I'm going to keep area of triangle. What was that? DCE or CDE, whatever you want to keep it. Let's keep it as CDE. See, in the first part, remember I found the area, the ratio of area of ADE by BDE. So the numerator is same here, but I have changed the denominator. So denominator is something different. Okay, but let's get back to this. ADE, what we will consider this time? Half into base AE, right? Base will be AE for us and height will become DM. Half into AE into DM. And consider the area of triangle CDE. Half into base EC into height DM. half into EC into DM. And here also very nicely, half and half get cancelled, DM and DM get cancelled, and you are left with this ratio, area of triangle ADE by area of triangle CDE is equal to nothing but AE by EC. Let's call it as 2. But remember, what did the theorem say? The theorem says that these two ratios should be equal. So I have got the ratio AD by DB also, and I have got the ratio AE by EC also, but I'm not seeing how to make them equal. See, AD by DB is my first equation. It is equal to this ratio of area of these two triangles. And AE by EC is a ratio of area of these two triangles. How do I make them equal? Anyone has any ideas? See, numerator is already equal. Somehow, if I manage to prove that the denominator of this BD area of triangle BDE is equal to area of triangle CDE, then this 1 and 2 will become equal, no? These two are already equal. If I somehow prove that the denominator is also equal, then these equations will become equal. Are you able to understand the logic which I am trying to explain?
Yes, sir.
Okay, now look at these two triangles, area of triangle BDE and CDE. Do you have any reason to believe that these two will have equal areas? Have you learned any theorem, anything in your past which tells that the area of these two triangles will be same? Remember what we know. We know that DE is parallel to BC.
So we can do half into the base and height, sir. Their height will be equal, sir. And base is also equal, sir.
Okay, so which base you are saying is equal? What is the base?
D is, sir.
Okay, so you want to consider DE as the base, and what will be the height? We have to drop a perpendicular line, something like this. That's what you're saying? Yes, that will be
Yes, sir.
that will be one way to do it, that we can prove, because these two lines are parallel. So no matter where you drop the perpendicular, if you drop the perpendicular here or you drop the perpendicular here, they will be same. But there's a better way to do this. Have you ever learned a theorem which tells you that if there are two parallel lines, you have triangles drawn between the same base with between the same parallel lines? Have you ever heard of any theorem like that? Area of triangles with the same base between the same parallel lines is equal.
No, sir.
No? You studied?
Last year.
Last year you studied this. Okay. So if you have parallel lines, you can understand by simple logic. Let's say this is your base AB. And if I draw a triangle like this, okay, let me keep an acute triangle itself. Okay. So AB is the base. What will be the height? I will have to drop a perpendicular. Let's say this point is E, or let's drop it, call it as C itself. So to get the height, we have to drop a perpendicular from here, and we will call this as height.
Yes, sir.
Okay. Now with the same base AB, let me draw some other triangle. And this point, let's call it as D. So if I want to find the area of the triangle ABD, I will again have to drop a perpendicular from D to the base AB. So it will be height will be something like this over here, right?
Yes, sir.
And can you understand that if there is a parallel line, the perpendicular distance, whether you drop it here or you drop it here, both are going to be same only, no? The perpendicular
Yes,
distance
sir.
between the two parallel lines.
Yes, sir.
So height is same, And we have told already that the base is also same AB. So is it not true that the area of this triangle will become equal to area of this triangle? Half into base
Yes,
into
sir.
same height, half into base into same height. Okay. If I call this as base, then area of triangle, both the triangles is half into B into H. They are equal. So anyway, remember that area of triangles between the same parallel lines with the same base are equal. That is why these two triangles will have equal areas, because they are lying between the same parallel lines and they have the same base. Now base, you can call any one of them as base. If you want to call, they both have the same base, BC. DE will be the same base over here actually. DE is the same base and they lie between the same parallel lines. Okay. Or let me write it like this: area of triangle will be equal to area of triangle CDE. Why? What is the reason? They are triangles with same base DE between parallel lines. What are the parallel lines? DE parallel to BC. Let's call this as the third equation. These two are equal. Let's call this as 3. So from 1, 2, and 3, we can say that equation 1 and 2 are equal. PD by DB is equal to AE by EC. So do you people understand the proof? Will you be able to do this?
Yes, sir.
Okay, that's good. So you will practice doing this on your own. That is your homework. This is very important. This proof, you should be able to do it on your own.